For the second recording, I put some book pages on for the second recording. Those pages are incorrect. Your book, this particular textbook, does not have anything on this type of study. This was a different book for a different class. It's the neuroscience class that I sometimes use. Sorry, physiological psychology. So you can ignore the book pages on this particular one. You won't see anything of relevance on 518. But what I wanted to talk to you about was candel and aplesia. Does anybody know what the common term for aplesia is here? It's a sea slug. So I'm going to kind of share with you in a second situation here, kind of a method and result and a meaning once more. Kind of another very scientifically based study. So a sea slug. Anybody ever seen a sea slug before? So it's just a little, I don't know, I can pull up a picture, or if you want to pull up a picture of yourself. Actually, not of yourself. See if we can find a little picture here. Here's a picture. You kind of got a sea slug, you got a tail, you got a siphon, and you got a gill. And there's a mantle shelf. So this is a sea slug, if you will. So if you pull up even at home a picture of a sea slug, how exciting is this, huh? So in the first part of this study with the sea slug, what they do in stage 1, they'll just give a little weak touch to the mantle of the sea slug. Now, if you just give a little touch or even a little just small electricity there, what do you think will happen to the tail? Do you think you'll see much of a response from the tail? Just give a weak touch to the, what did we say, the mantle of the sea slug? Little touch leads to what? Kind of a little response. Actually, the responsive note, I said it a little bit wrong there. It's not the tail. The key response that we talk about is a gill withdrawal response. The gill, it has a gill in it for breathing. You'll see almost nothing for the gill withdrawal response. So if you touch the mantle shelf, you'll see just a very little, almost nothing for a gill withdrawal response. So repeat back to me what we said there. Touch what? Mantle, and see just a small gill withdrawal. So that was trial 1. Phase 2, what do you think they do? Think back to the conditioned emotional response. What do you think they do in phase 2 to the sea slug? Instead of just a tiny touch to the mantle, what do we like to do? Kate, what do we like to do?
Have them first full touch, I guess.
Not just a full touch, but instead of just touching, yeah, let's go with the electrical shock bit, right? That kind of seems to be the theme for the day. So on trial 2, they kind of give a strong electrical shock to the mantle. And what do you think they find for the gill withdrawal? You put a lot of electricity in, What will happen to the gill?
It'll be a strong response.
Yeah, a very vigorous gill withdrawal response. So kind of phase 2, if you will, or trial 2. Finally, in phase 3, what do you think they do again? Just a light touch again to the mantle. But what do you think the organism shows? Say again?
A response.
I didn't quite hear you.
A response.
What kind of response?
A gill withdrawal response.
And just a small one?
No, a large one.
A large gill withdrawal response. So kind of getting the theme here. Trial 3, they just do a mild or a touch to the mantle shelf again, and you see a vigorous gill withdrawal response. And this is in a sea slug. What a nice little picture here. So this is Candell's research going on here. The question is, how come this is going on here? Why is there a change in what's going on here? We're not going to disconnect things at this point. What would a cognitive neuroscience, in a similar way to the other experiment, want to do with this situation, like Ledoux did on the previous one? What would they want to do? Figure out what?
What connection in the brain is causing a response?
Yeah, what's going on in a sea slug? A very simple organism in terms of neurons and so forth. What's going on inside the brain? They didn't disconnect anything, but why on trial 3 is this basically going on? And what they were able to uncover here is very interesting. What they were able to uncover is on trial 2, when you do that strong electrical shock, it basically opens up what's called an interneuron. There's an interneuron that kind of is connected between the mantle shelf and the gill. And they basically found with this interneuron, it releases serotonin. It releases serotonin. And so on phase 3, this previously weak connection, what happens on trial 3? You touch the mantle shelf, and it causes a release from this interneuron of what? On trial 3. Causes a release of serotonin, and it causes the vigorous gill withdrawal response. So that's kind of the method. The result is this very cognitive neuroscience-ly oriented. Again, Kate, why would you say yes to that?
Because they looked at the interneuron between the mantle and the
Yeah, they're looking at specific neurons. It's a very simple, he uses the sea slug because it's a very simple anatomical animal. It's just got a few neurons in it. But it sounds, once again, very type reductionistic, correct? Here's the neuron that controls this situation. So this is Candell, this is sea slugs, and this is the idea that this connection, this interneuron releasing serotonin, is causing this response. Why is this not cognitive neuropsychology? Say again?
They're not humans.
They're not human. They're not really trying to help anybody. They're trying to figure out where in the brain is this located, and what are the connections, and what are the neurons. Is that pretty clear for everybody here then? Any comments or questions? So, method and result and meaning of the first two. guys ready for our third and final situation here? This is kind of we kind of build up here. The third study is going to be our most important study here. So